There are two possible shapes of how you can draw cyclohexanes that alleviate angle strain. So we can take the two ends and bend both of the ends up, the left end here and the right end, bend them both up, and that's one possible way. Or we can take one of the ends and bend it up, and take the other end and bend it down. This one we call a boat structure, as it sort of goes down, over, and up, sort of like a boat. This one we call a chair structure, sort of like this is the back of the chair, this is the seat, and this is down by the legs. There are going to be a lot of things dealing with sterics in this section. And the first one is there's a problem with the boat structure. And the problem with the boat is that I've got two hydrogens on each of these carbons up here. These two hydrogens are kind of occupying the same space and they kind of run into each other. And so that makes this higher energy. So what we find out is that the chair is more stable than the boat by about 6.5 kilocalories per mole. Which means that 99.99% of molecules are going to be in the chair structure at room temperature. And the angles in the chair structure are 111.5. So there's very little strain. They're only off by 2 degrees. And if you remember, some of the other molecules, like water and things like that, have bond angles of 107 or 105. They're different ones. So a couple degrees isn't a big deal. So because chair structures are by far the most stable, we need to learn how to draw chair structures for different cyclohexanes. So as we get used to trying to draw them, we have to also think about where the substituents are on each of the chair structures and how we can use language to talk about each of those. So I'll draw more chair structures. There's two different ways you can draw chairs too. I can draw it with the back to the left, or I can draw it with the back to the right. So either of those are still chair structures. Now, at every position around the chair, there are two groups. In this case, there's nothing on this except for hydrogen. There are two hydrogens at each carbon around the ring. So what's important is to be able to learn how to draw where the different hydrogens are. So first of all, there's one coming up here, and then there's one going down here. Okay, and that will be true at every single carbon, right? At each carbon, there will be one up position and one down position. And if we draw the cyclohexane flat, you can see the same thing. At each position, we can have one thing coming up and one thing going down. A solid wedge means up, a dash wedge means down. Cannot have two things going up at the same position, and we can also not have two things going down at the same position. All right, so that's the first thing. At each carbon, all the way around, we need to have one thing going up and one going down. Okay, so this one is our up, so this one must be down. Okay, etc., and we can go around. Now also, at every position, we have one group that is axial and one that's equatorial. An axial group is something that's vertical, up or down. And we have an equatorial position at each one. And equatorial ones are horizontal. Again, they can be going up or down. So if I look here, this up one is vertical. That's my axial position. This down one is sort of horizontal and down. That's my equatorial. And you can go around the entire molecule doing that. I'll draw a little bit bigger one on the next page, and we'll go through every position all the way around. But what's important to notice is that here, let's do just one more. This position is down and axial, because it's vertical, which means that this next position has to be the opposite of both of those. So it has to be both up and horizontal, or equatorial. All right, so this time I'm going to go around the whole molecule and do all of the axials first, and then I'll do all of the equatorials. Now, there's sort of a trick for figuring out where the axials are, and that is every time that there's a point, see how there's a point here? The axial goes straight out of that point. So if the point goes up, like this one does, then the axial goes up at that position. If the point goes down, like it does here, the axial goes down. So see if you can draw in the other 4 axials then. This one goes up, so the axial is up. This one goes down, so the axial is down. This one goes up, so the axial is up. And this one goes down, so the axial is down. Now you notice these middle ones I'm drawing across the other bonds, but of course this position here is behind this other one here, if we're looking at it in 3 dimensions. So those are my 6 axials. Next up, we can put in the equatorials. I always start with axials because you can determine them by which direction the point goes. So if this axial is up, the equatorial that's on here has to be equatorial and down. So it's to the side and down. This is the equatorial. Right? The reds are all the axials. So now I've got an axial that's down, so the equatorial has to be to the side and up. I have an axial that's up, equatorial is to the side and down. Axial is down, equatorial has to be the side and up. Axial is up, equatorial to the side and down. Axial down, equatorial to the side and up.